Hey everyone, welcome back to my channel EduVibe. Today we will start with the another unit of the grade 11 chemistry, which is forms of matter, which is the gases. So we are more focused on the gases one, which is the gain the forms of matter, and we do the theory in this. We do the so many numerics, so many equations, so many formulas in this, and the starting unit is start from the gases one, and we have to know the properties of gases first. So our topic is ideal gases and the real gases. So the ideal gas and real gas are way different, and we have a difference and a similarities from this. And this is kind of a graph. So we start the second unit now. We done the first unit. If you don't watch that unit, you can check from the description and do that first, and then move on to the second one. So this is basically the unit B. So let's start with this properties of gases. So the gases are compressible first. So gases are more like compressible. So you can compress the gases as much as you can. So you can see that you can compress the gases as you can. So the volume of gas decreases. So from this, the volume of gas decreases dramatically when the pressure is exerted on the gas because molecules are spread further apart in gases than in liquids. So liquids, the gases are very not like far away. In gases, they are more far away. So they're easy. They have a low volume for that time. So when you exert the gas, so the molecules are further apart in this. So then you do the compressible as much as you can. Gases expand as the temperature has increased. If you increase the temperature of gas, so you can see this is like not very cold gases. When you heat it up, when you increase the temperature of this, you can see the volume of this. So they move faster. They have a more kinetic energy. So if the pressure remains constant, because the molecules are moving faster and they have a more kinetic energy. So if the pressure is remain constant and you increase the temperature only, so this will increase your moving capacity, faster moving, and get the more energy in this. Like in this, you can see. Next property is that the gases are very low viscosity. So thickness about. Talk about the thickness of this. So low resistance to flow. Gases flow through the pipes more freely than a liquid such as water. So you can see gases also move from the pipes very easily. Get the water. Water is like liquid form and gases are more freely in the pipes than the water. Gas will escape quickly. If there are a small hole in that pipe, the gas is like released that escape very quickly through small openings in the containers or the pipes or anything where the gas can be contained. And gases have very low densities than the solids and the liquids. So gases also have very low densities. They don't have very much density. Like you can see solid liquid gas, the gases are very dense, not very like uh, compressing that, they have a more space between the molecules. You can see liquids has a very minimal space, and they have like tight band. They are rigid. Solids are very tight packed. Liquids are very like not very tightly packed, but the liquids are free to move. So that means they have a lower tested densities. And the last one is that properties are measurable. So measurable means that they mix neatly and evenly with each other when you put something into a container. You put something in a container, as you can see, like in a container you have an oxygen. You put nitrogen in it. They mix very easily. They mix very easily with any kind of other gas or any kind of material with each other. Last, now we talk about the ideal gases and the real gases. So ideal gases and real gases are the on the theory of the KMT is a kinetic molecular theory. This provides the scientific model for the explaining the behavior of gases. So basically, gases have the behavior. They have ideal behavior. They have a real behavior. So the ideal gas and real gases come from the scientific model, which is KMT, kinetic molecular theory. So what is ideal gas? Ideal gas is like a hypothetical gas, not like original gas you can say, but hypothetical. Obeys all the gas laws perfectly in the law conditions. They will obey all the rules and perfectly in all the ratios. The laws we do it later on lessons. So that's all laws there easily like obey and the all conditions. Real gases deviates from the ideal gas under certain conditions. So real gases can be made from the ideal gas with the certain conditions. That conditions can be different. And the real gases behave very nearly like ideal gases as related to low pressures and the high temperatures. So there's a similarity between that. They are very like behave like nearly like same as relative. They have a low pressures and the high temperatures at such as STP and SATP conditions. What are those? We will discuss this. So just know that in that conditions they are very behave like similar. Real gas and ideal gases. The major difference. First one is that in ideal gases are very far apart compared to their size. They are very far apart. So these are gases, they are far apart. In real gases, molecules are forced much closer together and their size becomes significant. They are like forced to closer to the other and their size becomes significant. Their size are like different. In this, their size are compared to their size is compared to their how far they are. In this, their size are significant and they are forced to much closer together. In this, the molecules are in constant random straight line motion. No force exists between them. So there is no force in the ideal gases. They have a straight line motion, they have random motion, they have constant. So they are like not forces exist on this. But in the real gases, if you increase the temperature, if you decrease the temperature, like the property we increase the temperature, in this we decrease the temperature, molecules slow down. Molecules movement will slow down because the molecules movement will high when they have a high temperatures. But in real gases, if they have decreased temperatures, they don't move anymore. They slow down. At some point, the intermolecular force pressures may cause the molecules to stick together. If they are slow, they going to stick together, and when they stick together, not very tightly, so they become slowly and slowly they become liquid. So they become gas to liquid. That's all that. In the ideal gases. Gas molecules are perfect elastic collisions. Elastic collision means that very perfect collisions, elastic collision, where no energy is lost and collisions occur very quickly. High acid collisions can be occur very quickly and there are no energy is lost. In real gases, molecules of a real gas are more likely soft spheres. They are a soft spheres and shape change during the collision in bond ways little more so. Collision and involved in real gases that made the shape change. They change the shape and then little more slow as compared to iron gases. So you can see the iron gases are much better than the real gases. So you can see from the differences. The iron gases perform everything very perfectly, not like the real gases. So for example questions, you get the examples of the properties of gases like explain the properties of gas in that reason they give you. You have to explain that reason. Sometimes you get the theory question. You always have the theory question from this. You kind of MCQ, you kind of editor response, you get that type of questions. Explain the following absorb the properties of gases. So first one is gas pressure is increases when the volume of gas is kept constant and the temperature is increases. So this is the kind of the when temperature increases, the kinetic energies they move more faster. So in that you can write that if the increased energy of molecules results in the molecules colliding with each other, so they colliding with each other, and the kinetic energy is increases, and it will involve the container with more force. The walls of container will like more force on it, and they move more faster. Molecules move more faster. So you have to, when you write in the small paragraph form, you have to include that things. That when temperature increases or pressure is increases also. So colliding with each other, they kinetic energy increases and the molecules are more faster quickly. Next one, gas pressure increases with the temperature kept constant, the volume of gas decreases. The volume of gases decreases, pressure is increases, and temperature is remain constant. What is that? So, by decreasing the volume of the gas forces that molecule closer together, they will close together. You can see over there, over there, this one. They are more closer than the size becomes significant. So that's the thing you have to include in this. That In resultant of the decrease of volume of gas, the forces the molecules closer together, they will more closer to the other, and also they result in the more frequent collisions. They have more collisions between the molecules and the contact. So I have to include this all thing that they have a more collisions, they are closer to the other, and they do the between the walls and the contact. That's all you get. For this question, display that unlike an ideal gas, the real gas can condensate to a liquid when the temperature is low enough, as you say in the when we use a real gas. So what does the idea about the interaction between the molecules and why the gas is real versus the ideal? So there must be intermolecular interactions in this. So just one thing you get in it, you get the full mass. So we have we have the intermolecular forces, interactions. So that all we have discussed in the previous lesson that what are intermolecular interactions. We can check that lesson. So there must be some intermolecular attraction in ways which taking place. So which is not a property of the ideal gases. So they match that what they made the different. And that's what they made it different. So real gases have that property. This is the property of real gases of the intermolecular attractions. Not have the property of ideal gas. That's why they move to the tendency to the liquid. So go to the gas to the liquid. So temperature is low enough. So that's all you have to. That's main thing you have to include. That's all. So that's all for this lesson. We know the ideal gas and real gases now. The next lesson we do the temperature pressure difference and we do some questions now. So like I said, everybody, I do vibe, learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till then, stay creative with EduVibe.